All right, today we're going to look at compound and probability. Okay, this is the idea of finding probabilities of one event happening and then another happening. So we're contrasting this to what we did yesterday with ORs. Now this is AND. So basically two successive things happening in succession. The way we're going to calculate those is to multiply the two probabilities together. Okay. Now the big distinction that we're going to make here is between independent events which have no effect on each other, like rolling a die. Okay, if I roll a dice, each roll is independent of the other. One roll does not affect the next one. We can contrast that to a dependent event, okay, where if I'm pulling, if I have marbles in a bag and I'm pulling out different color marbles, okay, the second that I pull out one marble, okay, if I leave it out, okay, I have changed the probabilities for the next pull or the next marble that I pull. Okay, so we can talk about it in examples like that when we replace them versus when we don't replace them. That will obviously change the probabilities here. All right, so we roll a standard die twice. What's the probability of rolling a number greater than 3 and a 2? Okay, so we need to think about these two things independently. Okay, what are the odds that I roll a number greater than 3? That would be 4, 5, 6. So 3 options out of 6. Okay, that's the first probability. Okay, and a 2. So the second time I want a 2. Okay, now if I want to roll a 2, there's just one option there. Okay, just a 2 will give me a 2, so that would be 1 out of 6. All right, we multiply those two together and I get 3 out of 36, or 1 out of 12. We find the option here for 1 out of 12. All right, dresser drawer has pairs of following socks: 3 striped, 4 solid, 5 argyle, 4 polka dotted. All right, this is the one where we have to start thinking about whether we're replacing things or not. Determine the probability of choosing a pair of striped socks, replacing it, and then a pair of solid socks. So the idea is we are replacing it this time, okay, for each of the two of my choices here. All right, so the first time we think about striped socks. Okay, striped socks, there are 3 options. Okay, out of a total of 3 plus 4 plus 5 plus 4 is 16. So I've got 3 out of 16. All right, replacing it, so I still have 16 socks. And then a pair of solid socks. So I have 4 solid socks, which would give me 3 times 4 on the top, which would give me 12. 16 times 16 is going to give me 256. We reduce that, and I get 3 out of 64. And that's my final answer there. All right, second time, we're choosing a pair of argyle socks. Okay, so in this time I've got 5 out of 16, not replacing it, and then a pair of solid socks. All right, so now, this time, okay, we are not replacing it, which means instead of having 16 socks in my dresser, I have 15 socks in my dresser. Okay, we think about how many solid socks that I have here. Okay, I had 4 solid socks. Okay, multiply those two together, 20 on the top, still 16 times 15 on the bottom would be 240 this time. And that's going to be 20 out of 240 would be 1 out of 12. Okay. What is the probability of choosing a pair of polka dotted socks, not replacing it, and then another pair of polka dotted socks? Okay, so this time we're looking at the number of polka dotted socks that I have. Okay, 4 out of 16 for the first pull. Okay. If I'm not replacing it, then not only do I only have 15 socks here, but I only have 3 that are polka dotted. Okay, so I'll go ahead and multiply those two things together, 12 out of 240, which will give me 1 out of 20, which this one's multiple choice, so I look for that one, and I see letter A is 1 out of 20. All right, last thing here. Carnival has a lollipop tree game, which means you can select a lollipop of your choice. Some lollipops have a blue mark on the stick, which means you also win a prize. There are 250 lollipops to choose from, with only 25 of them having a blue mark. Once a lollipop is pulled, it is not replaced. Okay, if you select 2 lollipops, what is the probability that they both have a blue mark? All right, so here's what we're going to do on this one. Okay, so the first thing we're going to do is think about the probability that they are blue and blue. Okay, so in this time, the first time, okay, the first one we pick, there are 25 of them that have a blue mark. Okay, and then 200 out of 250. Okay, that's the first one. Okay, because because I want them both to have a blue mark. All right. The second time I pull it, okay, we're going to assume that we pull it on the first one. So there are 249 now because I'm not replacing it. Because remember, it's not replaced. Okay, if I pulled a blue lollipop the first time, okay, then there are only 24 left. All right, so what we can do is we can go ahead and multiply those two things together. Okay, you'll need a calculator to do that. All right, on the top of my fraction, I get 25 times 24, which is 600. On the bottom, I get 250 times 249, and I get 62, 250. And I reduce that. Okay, I can divide. Okay, so I can divide. I think I can divide both of those things by, I think 150. So if I take the bottom number divided by 150, that'll give me 415. And then if I take 600 divided by 150, I get 4. So my probability there is 4 out of 415. Again, the idea there, I wanted the probability, this was the probability of a blue the first time. Okay, and then this was a probability of a blue the second time when you don't replace it. Okay. All right. That is it for your notes today. Let me know if you have any questions. Otherwise, time is yours.